in the Sharjah Academy for Astronomy, Space Sciences, and Technology. I would like to thank you for joining us tonight. And our plan is to have this very unique planetarium, or virtual planetarium, by which you will be able to see the sky. You know our planetarium in SAST in Sharjah. I believe some of you have already visited us there and enjoyed the very large dome and the stars, the movies, the simulations that take place there every Saturday and every day from Sunday to Wednesday. But now, because of the situation of COVID-19, now everybody is staying home. And we still also recommend you stay home, and we will provide you with this service from home as well. I am also in my house now, and I'm trying to stream my knowledge and the technology available, which is the one that we use inside the planetarium to benefit all those who are really interested in astronomy and space. So thanks again. Mr. Ahmed is with me today as well. Yesterday we had a show in Arabic, and today we are extending the same facility in English. So let's start our journey from Sharjah to the outer space. But there is a main topic we will try every moment to talk about wherever we reach in the universe to mention it, which is about the what we call exoplanets. Now every month or every 2 weeks, sometimes, or every week, sometimes even, we discover some planets that don't orbit our star, the sun, but they orbit the other stars. What stars? Go outside after this show and look up. Look up. I know if you are in the city, you will not be able to see that number of stars. But if you are lucky and you see some stars, those are the stars that we are talk about. So please try to imagine them as solar systems, just like planetary systems. Usually, when we talk about planet, that means it orbits a star. Some stars are very bright and we can see them easily. Some other stars are not. They are very faint. Even some of them are very close to us, like the very closest star to us, which is Proxima. Proxima is only 4.3 or 4.3 light years away only from us. It is a huge distance. It's estimated to about 42 trillion kilometers, to a trillion, million of kilometers, 40 million kilometers, which is, of course, as everyone says, astronomical numbers. But that is very close if we compare it to the other distances to the other stars and objects. Actually, what I'm saying is, even it is very close, Proxima, uh, but it is not visible to our naked eyes. Even you need large telescopes, not very large, medium-sized telescope, to detect it. Nevertheless, we found a planet orbiting that one, which is Proxima B, or Proxima B. So this is actually, it is considered to be an Earth-like planet, which is very good news to everyone to know. Oh, so it is cool to find a planet similar to Earth. That means it could have liquid waters, it could have atmosphere, and maybe living creature. And if we go even beyond that, we will talk about intelligent life, intelligent creatures that we can communicate with. Okay, that's maybe good news, maybe bad news. We don't know what the nature of those, if any. So, so let's now try together to see how the sky would look like if we go now to see the sky without the light pollution of the city. Before that, I would like to mention one thing here before we go to that. Here is the exoplanet that we found, was found in 2009, I think, and it was actually voted for the UAE or Sharjah in particular as a member of the International Astronomical Union uh, because of 100 years, actually, the anniversary of 100 years for the International Astronomical Union. So they gave most of the countries, or the members actually, only the members, and the UAE is a member, and Sharjah in particular. So because of this, they gave us some stars to name them after the country or the government or even by a city within the country. So the star was given Sharjah itself, and the planet itself is named Barjir, which is a small city in Sharjah. So the distance is about 47 light years. It lies in Scorpius. This is Scorpion, or the Scorpius constellation. It is almost here. You see here, if we look up in the sky, we'll not be able to see it because it is not visible to the naked eyes. Uh, and these are our planets in the solar system. Here are some dwarf planets in the solar system. We'll not go this way, by the way. It is not a presentation like this is not PowerPoint, but this is all introduction. We will go to the outer space by another program, by it is a simulator actually. Just stay with us, please. So here we see the dwarf planets. One of them is the famous Pluto, which was kicked out from the planets, not from the solar system. It was never moved, and nobody can move it from the solar system. It is there orbiting the sun as before, just beyond Neptune, and some parts is actually it comes within Neptune's orbit, doesn't matter. But what I want to say is Pluto, and beside other four objects smaller than planets, have been considered to be dwarf planets, not planets, because planets are big a little bit, to be honest. So these are smaller than the other planets, by the way, smaller than Mercury. All of them are smaller than Mercury anyway. Okay, and even smaller than Moon, even not only Mercury. Here is our Milky Way galaxy, and here is our star, the sun. I will see my other laptop as yes, I see. You can see here a small dot here. We don't need maybe this one at this moment. I will remove it. So need only to see here. You see here a small dot that represents our sun or our solar system, even smaller. So we cannot see our sun actually from here. It's too small. If this is a mobile screen here, so we need to zoom in maybe 100 times before we be able to see it, or tens of times. And this circle is all stars that we can see naked eyes. And this big one actually is where we search for exoplanets, our area of exoplanet research. And sometimes we found actually very far exoplanets, maybe here, close to the center of the galaxy, to be honest, but that actually is not the normal case. That actually required a very specific method. There are many methods, about six to eight methods or more even, to find exoplanets. This actually required one of them, which is called the micro lensing method, which is not very common and not very applicable for everywhere in the sky. So most of the exoplanets we found are actually lie in this area. Now let's go to our journey. Now we are now in the universe. We see our planet, the Earth. Now it comes in front of the sun, so it means we are on the night side now. And our plan is to first to go to Sharjah. So let's go to Sharjah first, and from there we will talk about this sky and before we go up, let's go to Sharjah. My okay, ladies and gentlemen, boys and girls, if any. So this is actually our sky in Sharjah, and what we are looking at now is the northern direction. This is north actually here, and we see many stars. But what stars are those? So let's now try to find out with my colleague. I hope Ahmed is one of the astronomers in the planetarium. Are you there, Ahmed? Would like to talk a little bit about the sky and about the constellations in the north and the. Are you there, Ahmed Salahuddin?
Yes.
Yes, okay, that's good news. So Ahmed is one of the very good astronomers in the Sharjah Academy and the planetarium. So please tell us, Ahmed, about the sky. So what we can do, and I will help you here from my place. I know there is actually a shortage of time or what we call delay, time delay between us, but no problem. I believe all people will be happy to see an astronomer like you. Please to talk about this guy.
Well, yes, it's a good thing that we can do this online now and we can have a virtual sky instead of going outside and having to face the dangers of the virus. Well, now what you're looking at right now is the northern direction, which is the visible northern direction from any location above the equator. So we chose Sharjah because we all are in the United Arab Emirates and we believe that we are in Sharjah. From Sharjah, we can actually look at the northern sky and find out a very important thing, which is finding the direction. So let's imagine we didn't have that n, the letter n in there, and we need to find out the direction. So what do we do? We normally what we do is we use a very nice asterism. Asterism is actually a group of stars inside a constellation. So before we go to an asterism, let's talk about what is a constellation. We all know constellations are in the sky, but they are not real objects. They are actually imaginations from the ancestors who were really astronomers who changed the sky in a way that we have a map. So these, what you see in front of you, those lines you see are actually constellations. So you can see a dragon kind of constellation here, if you can see the mouse moving around it. And we can see on the right side, we can see Hercules, the dancing god of the Greek mythology. and down below we can see Cepheus, the king of the empire of that time. So what we're interested in right now is the Big Bear constellation. The Big Bear constellation is actually the constellation in which there is an asterism. So you can see the whole constellation is big, the Big Bear, Ursa Major in the Greek. The asterism is actually a small part of it. So you can see the highlighted part of the constellation is actually called the asterism. This is the asterism called the Big Bear. In Arabic, we call it Al-Banat Nash al-Kubra. So the Big Bear constellation consists of 7 stars, and all these 7 stars are actually named after Arabic origins. So we have the first star at the tip, we call Al-Qa'id, and then we have Al-Mizar, Al-Ilya, Al-Fakhdah, Maraq, and Dubba. And these are the stars named in series. So what we need to do is actually connect a line between Maraq and Dubba, which are the 2 stars, we call them the guiding stars. From these 2 stars, if you draw a straight line, 7 or 5 times actually the length between Maraq and Dubba, we shall reach a very important star. And this important star is called Polaris. We all know that Polaris is actually a very important star because it always shows us the northern direction. All we need to do is just find the Big Bear, and then from there the asterism Ursa Major, the the Big Dipper. From there we can find the northern star. If you find northern star, that means we actually look at the northern direction. Northern star is a part of the constellation called the Ursa Minor, which is Al-Dubb al-Asghar, or the Little Bear, and it's a part of it. So let's actually now see the motion of the sky. Why is Ursa Minor important? Why is Polaris important? Before we move this, okay, let's move the stars now, and also let's draw a line called the meridian line. And the meridian line is actually the line that splits the stars, that splits the sky in 2 halves. So you can see the Polaris position is actually around 24.5 degrees or 24 degrees, let's say, and that is the latitude of Sharjah. So if you're in Sharjah and if you look at the northern direction, you actually see Polaris exactly at this spot. It will never change. Notice how the time is moving, and we still don't see a motion. We still don't see a change in the position of Polaris because Polaris is actually the pole star that never changes its location. So if in Sharjah, if it's at 24 degrees, where will it be in London? It will be at about 50 degrees. So it will shift the sky, or the sky will shift according to where we are. So let's put the time, or let's remove the atmosphere. Yes. You can see the sun rising, but we have removed the atmosphere very cleverly so that we don't have any interference of light, and stars are still visible. So look at the sun there, and stars visible at this time. The only place where this is visible is actually when we are in the outer space. Outer space doesn't have atmosphere, so we can see the stars and the sun at the same time. We shall see that once we launch from Sharjah. So this is how we can find Polaris. Now let's see the rest of the constellations. Splitting the sky, we'll have 88 constellations. So right now we don't see the entire sky. In the planetarium, we'll be able to see the 360-degree sky, but unfortunately on the screen, we'll be able to see half of it. So these are the stars you can see and constellations formed. So every constellation has boundaries, and every constellations have the images. Notice how the sky is moving, yet Polaris is still fixed at the same location. We are now shifting the sky to the other side, so you can see the rest of the constellations. The yellow constellations you see are actually the zodiac constellations. In front of you, we can see Virgo, we can see Leo, we can see Cancer, we can see Libra, we can see Scorpius, Ophiuchus. So these are the constellations of the zodiac, which is the path or the imaginary line through which the sun, the planets, and the moon pass through according to us. Now we can see the images or the imaginations of the ancestors behind these constellations. Let's actually make, if we can make it a little bit thicker, the images, if we can go to the properties of the images and make it more thick, actually we can be able to see it more clearly, but still it's pretty clear. We can see the cross, we can see the Cygnus, the Northern Cross, which is the first constellation in which the black hole was discovered in 1974. Our next topic in the next week will be black holes. So please tune into the same link so that you can actually watch the show about black holes. This is the motion of the sky. Very beautiful to see the motion of the sky with the constellations. So the constellation images, as most people think that they are there in the sky, but no, it's not there in the sky. It's actually imaginations, and it's a way to make a map for the sky. Also, the ancestors used the constellations to figure out the time of the year or the season of the year. Where are we? And the farmers used to use these constellations to know when do they need to do certain cropping or crops because they don't grow every time or every month of the year. So they use the constellations for that sort of help. All right, so this is the constellation story, and now we shall continue. Let's continue with
Thank you,
Marwan,
Ahmed.
the rest of it.
Great, thank you very much. Just stay beside me because you have good knowledge in astronomy, and I believe the audience need you to help them in another part of this session, which is 60 minutes in the outer space, guys. So just stay with us and keep home, as we said. Thank you very much. So let's start our second journey. Our second journey will be definite. Our second journey is we will actually travel from Sharjah to the outer space. So stay with us and see how we will move to the outer space. So please just stay in your seats. And now the sun is coming from the east, as you see. Maybe you can see here the sun is coming, which is daytime now means. And now let's travel to the outer space. This is the meridian line. We don't need it. We actually it's not required for our journey to the outer space. It's required when we see the stars and would like to see the altitude of the sky of the stars to mention them in a scientific way. But now we are going to the outer space anyway, and this coordinate system is not required there at all. So let's go. Three, two, one. Let's go. That is actually what you see now is the Earth and the Moon together. I will enlarge the size of both the Earth and the Moon to see them properly. Now we look from the north, as I think, and if we speed up time, then we'll be able to see how both are moving. Now this is how the moon is orbiting the Earth and me, and how the Earth is orbiting the sun. Let's move on to see the second scale in this journey, which is the solar system sizes, or the scale of the solar system. Now we see the orbits of the planets. You can see this is the orbit of the Earth. This is Mars. Wow, great. We can see Mercury, Venus, Earth, and Mars. Mouse is not responding at all. Unfortunately, it is not responding. Okay. Now we are traveling even further from the solar system into another scale, the galaxy scale. Ahmed, are you with us?
Yes.
Okay, so please let's talk a little bit. If you, I know you know about the galaxies. So how many galaxies are there, Ahmed? Do you think?
Well, until up to 2018, I believe when I did the shows, I used to say we have 200 billion galaxies. That was the number we always fixed on. But after that, we had a new survey that came out from Hubble Space Telescope that said the universe could contain up to 2 trillion galaxies visible to us. So our visible universe contains up to 2 trillion galaxies that we have observed
Wow,
and we have
wow,
surveyed till today. And Milky Way is one among those trillions of galaxies in a very large.
wow! This is great. Can you imagine, ladies and gentlemen? We're talking about 200 or 2 trillions of galaxies. 2 trillions, 2 million of million. Okay, if you have million galaxies, and that is in one area, so you need million similar areas. Everyone has million galaxies. You have two of them. This is what the astronomers or the cosmologists think actually, but that is what we call the observable universe, and we will talk about that. Okay, Ahmed, please continue.
Yes, so as we see right now, we are in the side view of the galaxy. We think galaxy is big. Yes, indeed it is big, but it's actually more than big. We call it, it's actually spiral and very spiral actually. But its thickness or the width of the galaxy is not really that much. It's about just 3,000 light years across. But the actual distance of the galaxy from one edge to the other edge, if we zoom out a little bit, we can see that from one edge to the other edge, it might be about 100,000 light years. That means if you send a beam of light, or if you send a laser pointer from standing from one edge, it will take that one laser pointer 100,000 years to get to the other side. And the center of the galaxy, there's something called a supermassive black hole. You can see a big bulge at the center. We call it the bulge of the Milky Way. Don't mistake the bulge for the black hole. It's not actually the black hole, but the bulge is actually the bulge of the stars, or the high density of stars at the center of the galaxy, which results in the supergravity field or gravitational field of that supermassive black hole. There are two kinds of black holes actually. One is called the stellar black holes, and the other one is called the supermassive black holes. Stellar black holes are the ones we can find anywhere in the Milky Way. There are millions of them in the Milky Way. Any massive star that could be the mass of the sun, between 10 to 10, 20 times mass of the sun, if it dies, it becomes a stellar black hole. But a supermassive black hole has to be the one at the center of the galaxy, controlling the stars in orbit. The diameter of the galaxy's black hole could be up to the distance between the Earth and the sun. And the gravitational field is crazy, as the mass of the black hole could be about 4 million times the mass of our sun. This is the side view of the Milky Way, as you can see. It's actually very thin, and it's filled with galaxy stars. More than 200 billion stars are there in our galaxy. It's a very spiral galaxy, and that's one of the shapes of the galaxy. There are four shapes of galaxies. One is spiral, one is barred spiral, one is elliptical, and one is irregular galaxies. Our galaxy is actually a barred spiral galaxy. Now we are leaving the Milky Way and the local galactic cluster. We are now looking at galaxies beyond the Milky Way. We are about to see the 2 trillion galaxies that we observed through the Hubble Space Telescope. Different colors of galaxies. You can see Andromeda galaxy here on the left hand side, which is the largest one in the local group. Our Milky Way is only second to Andromeda. The rest of the galaxy you can see around different colors of stars, depending on what color of stars they are, how old the stars are, and the temperature of the stars. That's a whole other story. And now let's see how the universe looks like if we travel to the edge of the visible universe.
Ahmed,
Now,
what about exoplanets, Ahmed? We are at the level of the galaxies and the clusters of galaxies. So, what do you think about the exoplanets when we talk about discovery of exoplanets? Are we here? Are we there? Are we at this scale of discoveries? What do you think?
oh yes, we definitely are in the scale of discovery of exoplanets. Exoplanets have been discovered inside the Milky Way. We have been looking outside, but the inside, first we have to check our house. Inside
Mm.
our house, we'll find exoplanets. Inside the Milky Way, yes, we did find more than 4,000 exoplanets using different telescopes, from ground-based telescopes, even from space telescopes like Kepler Space Telescope. And then we have TESS, which is the extraterrestrial survey.
Yes, I love it. I love it. This one, yes,
TESS
yes.
is a big project for finding extraterrestrial life, and I think we will find someday about some kind of contact.
We may talk about it someday, Ahmed, maybe in
Yes,
a
of course.
special event. It's a great, really great one. So I believe that maybe if we just make some special talks about those exoplanets discovery telescopes and terrestrial and orbital ones, it would be great. Yes.
Yes. So we do have a lot of exoplanets inside the list of exoplanets that we have, 4,000 of them. About 400 to 500 exoplanets actually kind of give you hopes that it could be Earth-like. What do you mean by Earth-like? When you say Earth-like, there are many factors, not just like it looks like the Earth or it has 7 billion people on it. The factors talk about how the distance of the planet from the parent star is.
Ahmed,
Yes.
What, Ahmed, what do you think if we go to that scale of the exoplanets? I want you to talk about them when we reach to that scale. I just want to talk a little bit about these colors. So what do you think these colors now before we go back to the level of the exoplanets and we talk about them while we see them? Now we don't see any exoplanets as you said, and with this
No.
not the scale of exoplanets. We talk about now the edge of the universe, and I don't think that is where we talk about them. So what do we see now? Please tell our audience about what we see now.
What we see right now is actually called the visible universe. We are at the edge of what we have observed. So until today, we observed a lot of space. And from the observation, this is the edge of it. So we mentioned about the trillions of galaxies. What you see right now in front of you are the galaxies observed by the telescopes. But we have not been there physically, or not a telescope has gone there to take this picture. These images are taken by modeling, the 3D modeling of the images. So what we do is we take pictures of the space, of the deep sky, and then we put them together and create this sort of a 3D model. This will help us understand the shape of the universe that we are in. But as you can notice, there is a gap in between the galaxies. You can see two gaps. It looks like a butterfly shape. You can put the mouse there and you can actually see it. These gaps are not actually empty gaps. Yeah, these are the gaps we talked about. These are the not empty gaps. These are actually gaps filled with galaxies, but we don't know what's in there because our Milky Way is blocking the view. So until we develop
Do you mean
technology,
the dust? Do you mean the dust in the Milky Way?
yes, the interstellar dust, even the density of stars can actually come in play. It can block the view of the deep sky. So these two areas are not yet observed until we figure out some other way to find it. But the rest of the colors that you see around you is called the CMB, or the cosmic microwave background. This cosmic microwave
Yes.
background is actually the energy patterns or energy survey done by telescopes. And we have figured that this is actually radio observations. So this was actually accidentally discovered by two astronomers in their radio laboratory. And then after they accidentally found this, they were like, there is some kind of emission, some kind of radiation that we see in the deep sky. What is it? So they started researching on the same topic, and they found out that it's actually the remaining energy from the Big Bang that happened 13.8 billion years ago, which actually radiated throughout the universe, and there is still this energy around. So you can see different colors, you can see dark colors, you can see bright colors. These colors actually depict a specific temperature in the deep sky. So what we are at right now is actually minus 370 degrees Celsius, or Kelvin, 3 Kelvin, that we can see that We are at the edge of the universe, but it's not actually the real universe. It's actually only the visible universe.
Yeah, thank you, Ahmed. Now, guess what I'm doing now? We are now going actually back to our home. But what home? We even cannot see our galaxy. We cannot see even our local group of galaxies, the 50 galaxies that we belong to, or our galaxy Milky Way belongs to. So now our now aim is even just to find the galaxy, the Milky Way. Oh, I see. This is, I think, our galaxy, the Milky Way. So you can see it if you want there, here. I see it in the other laptop. I know it is not as smooth as I see here in my main workstation, but doesn't matter. So now we are very close. We are within the galaxy now, and what we see now is, look here. This is amazing thing, very amazing thing. So Ahmed, what do you think? What are these lines? So what would you say to the audience about these lines? Why we have
I personally feel like these are lines. Some child came and drew some lines, and it doesn't make any sense because I don't know what these lines are. But what I think it is, from this point of space, we don't really know what it is. But from looking at this part of the galaxy, I think the sun is somewhere in that point. So I have a feeling that these lines actually are the constellations that we saw at night. So if we go closer inside the galaxy, these lines will actually come back to their shapes, which were the shapes that we saw
Yes,
earlier.
exactly. Yes. So if you remember, ladies and gentlemen, the lines of the constellations that Ahmed spoken about them at the beginning. So those actually exactly the lines that the ancients actually imagined when they made that beautiful game by connecting the bright stars each to other to make those perspectives and those mythology. So these are the lines. So at the middle, as Ahmed said, that's the center. So this is the not only the area where the solar system is, but the size of the solar system is very, very small at the center. That's where the sun is. But the ends of these lines where the stars lie from our solar system. If the solar system lies at the center of these lines, so this is the farthest star we can see naked eye, and these are the stars we can see naked eye. So look how small is the area that we can see naked eye if we measure it or compare it to the galaxy size, very small. So we cannot see these stars here. We can see here as what we call the Milky Way, what the is called the Milky Way, which is the cloud crossing the sky, but we cannot see stars, individual stars. So let's go through that to see whether if we are in our right place. If we are mistaken the place, the location, that means we will not be able to see our uh, common and very well known and famous constellations. Let's see. So what do you think, Ahmed? So what will we see?
I'm expecting to see the yellow lines to be the zodiacs.
Okay.
I'm expecting to see the red ones to be Ursa Major, Ophiuchus, Hercules, maybe Dragon, and all
Wow.
constellations that we saw.
Okay. So if those lines now came together and align together in a certain way, give us what we know as constellations. This means that we are going to the right place in our in the
Yeah,
galaxy,
we'll
which
be
is the
heading
solar
to the
system. Look,
brightest.
can you identify any constellation till now? Not yet, right?
I don't
Not
think so.
yet.
I think
Look. I can. This is Aries. I think this is Aries. Oh, I can see dragon.
that's the planet.
That's
Yeah,
it. Yes, that's the Draco, the dragon. Wow, this is Little Dipper, right? Where's the Dipper, Big Dipper here?
yeah. We can see the shortest constellation in the same line. It's
Yes,
Lyra.
yes,
Lyra is visible with Vega.
yeah. This is Lyra and this is Vega and this is Deneb. Deneb,
Yes.
very far star, by the way.
Yeah.
If you just, yeah, exactly. So this is the solar system at the center. So we are coming close to the solar system. Neptune, Uranus, Saturn, Jupiter, Mars, and we are close to the Earth. Wow. And from here, we would like to talk about from our planets, from the center of the galaxy of the solar system. Here, we would like to talk about the not our planets, the planets of the solar system that we see right now. I will enlarge them a little bit so people can identify the planets. So these are the planets of our solar system here. So what about the exoplanets? This is what we are going to talk about. If you remember the very first slide I mentioned, so let me go to it for a while. Yes, this is the one. We said here is the solar system. Here is all stars that we can see naked eye. And here is the area where we usually explore the exoplanets. Okay, so let's see now. We are there now. So we should see the exoplanets everywhere here. Okay, back to our solar system and live journey. Now from here, I would like now, Ahmed, and please be ready to talk about the the exoplanets, or what we traditionally named before the extrasolar planets before exoplanets came. Okay, so I will push the button that shows us those extra solar systems. Yes. Wow. I'll disable the names now. This, please, Ahmed.
We could remove the constellations so that we can actually see the amount of the exoplanets that are visible. Yes. So these are the spots in which we have observed exoplanets. So you can see the blue circles. So what we're looking at right now is exoplanets in other systems. So this is one solar system that you see, the sun and the planets. So exactly like this system, we have other systems out there in the galaxy. So every star in the galaxy could be actually a host to planets. Every star could be a parent star with children, and these children are supposed to be the planets. So from this image, you can see that the Kepler Space Telescope and the assisting telescopes on the Earth and also in space, they actually keep an eye open on any kind of exoplanets visible. So the method that they use to find the exoplanets actually is called a transiting method. So any star, if you see, if there is a small change in the light coming from the star, that means there is something that's come in front of it or moved in front of it quickly. So whatever that moved in front of it for a fraction of time, that can be helpful for us to find out the size of the planet, the speed of the planet, also the mass of the planet in some cases. So that's how we actually figure out all these exoplanets in the galaxy ourselves, and only in the Milky Way, by the way. All these dots you see are in the Milky Way, nothing outside Milky Way. That's one way.
Yeah, yes, exactly. Thank you very much, Ahmed. And actually, I would like just to mention the size of these circles means the size of the exoplanets been discovered there. So the bigger actually in the image here, the bigger in size. And what do you think if we just try to see the location of Sharjah exoplanet and Barjir? So
Al-Burjir,
what?
yes, of course.
So where should we look? Do you think where to look? Yeah, now so we need to
We need
look
to find,
somewhere.
yes, we need to find the exact position where it was observed.
Yeah. So the constellation of Scorpius maybe. So let's
Scorpius,
see the
yes.
constellations. Oh, we are lucky. It is just in front of us. So
Yes,
I
that's right.
will. Yes. So it should be actually somewhere here. I think this one. Yes, it should be this one here. So let me just now put the names if to make sure if I am right or not, just to add the labels. I'm not sure if it.
It's
Yes, it is HD 141937. So that
yes.
is the exoplanet. I don't think we can move to it. I don't
Zoom, we
think.
can't really zoom into it. I
No,
don't
no,
think so.
no,
No,
no.
no.
No, it is.
But
It is
just to
not
make
like
it
that.
clear
It's
for
not
the
that advanced.
yeah,
Not that
just
advanced.
to make
Yes.
it clear for the
Yeah.
audience, the HD is actually the code given to each exoplanet we discover, and Burjil is actually the name we give it to it. So
Yeah.
planets have their
Yeah.
names,
Yeah.
also they have their codes depending on the stars they revolve around.
Yeah, yeah. To be more specific, the HD is the code or the name given to the star, the parent star,
Yes,
the star
yes.
that the exoplanet is orbiting. Yes, and it's not always HD. Sometimes you have different names because of the different catalogs that you look at. GJ, for example, here you see different numbers. If we go to different areas, we see different names. Yes, exactly. And so this is the some of the exoplanets. Now, how many exoplanets are there? Now, I think until today or yesterday, actually, to be honest, about 4,152 exoplanets has been discovered till now. Let me just, this is not updated, so let me do an update. I will
As of
check
1st
actually.
of May, there are 4,260 confirmed exoplanets. As of
So
1st of May
I will
2020.
yes, yes. So let me go to what called NASA. Uh, I will show you even on the screen. NASA exoplanet archive. Now I will take this to you here. No, not this one. Yes, it is coming.
Hello, everyone. My name is Brian Schmidt, and today I'm going to tell you about the accelerating universe. Now, the accelerating universe is not a story
Something
that is just my
is
own. It really is a story about cosmology
just a
and the
minute.
100
I
years
think
of development over the past century. And so let's first start with a tour of the universe. And the
one
first thing I want to say is
is
that the
running.
universe is big. Now, to understand just how big, we're going to use the speed of
Okay, sorry for this. But this is actually the official website. Okay, so let's open the mics for questions, Ahmed. If you
Yes, of
yes,
course. If
here is as you see. Look here. This is the total number of exoplanets being discovered till today, 4,154. 2 days ago, it was only here two actually. No, not 2 days. One a week later, 52. So every several days we found different ones. And now maybe tests. This is the test. How many candidates? But this is the confirmed from test. This is the candidate. Okay. Any questions? So let's see if there's any questions from the audience
all right,
in what
so
we have seen so far.
we can ask them if anyone has a question. Please, can you can do the raise hand option in Zoom. If you do the raise hand option, we can see the hand and we can unmute you, and you can actually speak, and we can all listen to your question. If any question, please do a raise hand.
In Zoom, actually, we can raise hands, by
Yes, we
clicking
can
on
do.
participants and go to the bottom of participants after you open the that is the raise hand. I maybe here. Can you see here? If we go here, no, not here. Somewhere else. Where to go to raise hand? Or maybe the same, but because I am admin, this is why it's not available for me.
Yes.
Okay, so no problem. No questions. If you open all microphones, maybe they are they will
Okay, I'll
enjoy.
open the microphones now if anyone wants to speak.
Yes.
Thank you very much.
Well, yes,
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 please.
thank you very much for everything, for your great efforts.
Most welcome.
This gives us more faith in Allah's greatness and power. These
Yes, indeed.
facts mentioned in the Quran, but we don't know
Yes.
everything. You are just adding a lot of
No.
information to our knowledge.
Exactly. Yes, and this is continuously. We never end up with the result, complete result, and integrated result to know everything about the universe. That I don't think we'll be able to reach someday. But we are in the right direction because science, as I always say, is the best tool for having knowledge. Please, if you have any questions, Mr. Wael, please.
No, not too much. Just joined and having a lot of entertainment in this.
Yes. Did you enjoy that?
Yeah, very much, very much. I'm happy that even my daughter joined late. My daughter is 11 years old.
Yeah. Yes, please, together. So actually, what we are doing now every Saturday at this time from 10 to 11 in Ramadan, we will be here together. Please join us with your friends, everyone. Send them, I mean, everyone from his or his home, of course. Don't get it together. Okay, and so let's have the questions and answers.
I think on Friday it is in Arabic.
Yes, exactly. Friday, الجمعة بالعربي, yes, in Arabic.
شكرا سيدنا.
So you can actually see both together, Mr. Wa'il. Barakallah fiqh.
شكرا مستر مروان.
Inshallah. Next time, Allah Hayyik. So we'll be talking about how to sight the moon sighting for inshallah, beside the black holes. We will talk about black holes, but beside that, we will talk 5 minutes how sighting the moon for Shawwal will be in the actual sky. Yani we will do it here virtually, inshallah. So try to be with us both Friday in Arabic and Saturday in English. Yes.
Thank you very much. Assalamu alaikum.
Wa alaikum assalam wa rahmatullah, Mr. Wa'il. Thank you very much, ladies and gentlemen. Thank you, Ahmed. And so let's, inshallah, meet again or see. This is everything for today. And next week, Friday, will be in Arabic and in English about the black hole and the new moon sighting for Shawwal. And stay home and be with us and with the virtual planetarium at the Sharjah Academy for Astronomy, Space Sciences, and Technology.
Sorry, Mr. Marwan. On Friday.
Please, تفضل.
On Friday, we are sighting the moon, but it will be clear, yeah?
Yeah, actually, in Friday, actually,
Friday 29.
Yeah, 29. So actually, no, it will not be clear. Friday, we will talk why actually. Of course, after the event is happening, that will be actually at the sunset time.
Sunset,
but we will meet here. We will meet here after 10. So means we will talk about the past for 4 hours, 5 hours previously. But actually, the moon will not be visible that time, and we will explain why. Please be with us.
Yes.
Okay. Inshallah. Thank you very much, and Assalamu alaikum, and stay home, guys. Assalamu alaikum.
Assalamu alaikum.